So now that we know how to restrict a line, now we can talk about how we can join multiple lines together. And we call that a piecewise function. When you join multiple functions together, we call that a piecewise function. The way it works is we just restrict the function to be developed as multiple things at the same time. So for example, if we say f of x is equal to, and then we use curly brackets, 3x minus 2, while x is less than or equal to 4. And then we could say is negative 2x plus 1 when x is greater than 4. So you can see we're restricting the values of x. So let's actually draw this thing. So it's essentially two linear functions all built into the same thing. So 3x minus 2, and then we've got minus 2x plus 1. I'm just going to change this domain range, so I'm going to make it at 2 instead. So it's going to behave like this when x is less than 2 or equal to 2, and it's going to behave like this afterwards, when x is greater than 2. So let's drop some axes. So the most interesting point on this function is what happens at 2. So let's start there and we'll go have a look. So first of all, let's split this up into two functions. We've got y1 is equal to 3x minus 2, and we've got y2 is equal to minus 2x plus 1. So first of all, let's just sketch the first function. So 3x minus 2. So minus 2 is here. Gradient of 3x, well, we can work out some of the other points in it. So let's sub in x equals 1. That'd give us y1 is equal to 3 times 1 minus 2. 3 times 1 is 3 minus 2 is 1. And so our first point on this y1 would be 1, 1. And so we can see we're starting to get shape. Let's sub in x equals 2, because I think that's the most interesting spot. Well, when y1, 3 times 2 is 6, minus 2 is 4. And so we've got another point. So our first point over here was 1, 1, and the second point we found is 2, 4. So 2 up to 4. And you can start to see that we're developing a straight line. But notice I never have to sub in a number bigger than 2 into y1. Why? Because y1 is only defined up to 2. X has to be smaller than 2 when dealing with it. So the only other point I'm going to substitute in is x equals negative 1. y1 is equal to 3 times negative 1 minus 2. 3 times negative 1 is negative 3 minus 2 is negative 5. And we get another point, which is negative 1, negative 5. And you can see it all continues on. Now this is going to go down like this forever. And so I'm just going to put a little arrow on it. That is y1 is equal to 3x minus 2. With the domain restriction on it, x has to be less than or equal to 2. And because it's equal to, I'm going to put a solid point on the end there. So I'm going to recolor this one red, y2, and we're going to do the same thing for y2. Now y2 is only defined when x is bigger than 2. So the smallest number I can choose for it would be 2.00001, very, very slightly bigger than 2. But I kind of want to know what happens at the changeover point, where we go from the blue line to the red line. We'll do that in a second. Let's start with some more simple ones. Let's try x equals 3. Well, when x equals 3, y2 is equal to minus 2 times 3 plus 1. Minus 6 plus 1 is minus 5. So at 3, 1, 2, 3, we're at negative 5. So that's the point 3, negative 5. And we'll do one more point, x equals 4. We get y2 is equal to negative 2 times 4 plus 1. So it's going to be negative 8 plus 1, negative 7. So we can already kind of get an idea of the shape of this line. It's going to look something like this, pointing downwards. But this line does actually continue all the way to this changeover point here, where it changes from one to the other. And we need to work out where exactly that point is. So we need to substitute in x equals 2, meaning we'll have substituted x equals 2 into both y1 and y2. So x equals 2, we get y2 is equal to 3 times, oh sorry, not 3, negative 2 times 2 plus 1, which is negative 4, plus 1 is negative 3, and we get this point here. Except, think about what the domain is. The domain is not inclusive, meaning it's not going to be a solid point. It's going to be a hollow point. Let me get rid of the label for the other one. So it's going to be a hollow point here. And now we can connect it up. So this is now y2 is equal to negative 2x plus 1, where x must be bigger than 2. And this blue one over here is y1 is equal to 3x minus 2, where x must be less than or equal to 2. And together they form f of x. So the combination of both the blue and the red line is how f is defined. So f is both the blue line and the red line. It's multiple functions all at the same time. It's pretty powerful stuff. Now, what we can do is we can start playing around with this. So the first thing that we could do is we could ask a question like, what is f of negative 3 equal to? Well, negative 3, when x equals negative 3, is it going to behave like the top function or like the bottom function? Well, it should behave like the top function because negative 3 is less than or equal to 2. Therefore, it fits the definition of here, whereas negative 3 is not greater than 2. That doesn't make any sense because it's not true. Therefore, we're going to substitute into y1. So 3x minus 2, 3 times negative 3 minus 2, negative 9 minus 2, negative 11. The alternative question we could have asked is, when does f of x equal 5? Oh, let's do one slightly more interesting. Let's do when does it equal negative 5? Now, we actually already know the answer to this because we've done it previously over here, but we can have a look visually. When does y, which is f of x, equal to negative 5? Well, y equals negative 5 happens right here. And you can see that there's two solutions here. There's one on y1 and there's one on y2. Now, we're lucky that we have a picture in this case because we can just read them off. But it comes down to the fact that whenever you have a piecewise function, there could actually be multiple solutions that work. And in this case, we do have multiple solutions that work. So we're going to sub in y1 equals negative 5, and we're also then going to go y2 equals negative 5, because we should get two solutions for this. So solve for x. So when f of x equals negative 5, solve for x. So we get negative 5 is equal to 3x minus 2. Add 2 to both sides. Negative 3 equals 3x. Divide both sides by 3. And we get x is equal to negative 1. Over here, we get negative 5 is equal to negative 2x plus 1. And we can take 1 from both sides. We get negative 6 is equal to negative 2x. And then we can divide both sides by negative 2. And we are left with 3. X is equal to 3. And so these are the two solutions to when f of x is equal to negative 5. So here was quite a rushed introduction into piecewise functions and how to use them. We're going to be looking at these quite a bit. So I'll see you in the next one. Goodbye.